Okay, class, let's go ahead and solve some radical equations. And the thing that we need to keep in mind is we can introduce some extraneous solutions because the domain of a square root function is not a real number, so we can end up with some extraneous solutions. So to start off with the first problem, we're going to isolate the x by dividing both sides by 3. So we have x to the 4/3 is 81. And so we have, remember, x to the 4/3, it's the cube root of x to the 4th. So I can go ahead and take the 4th root of both sides, or I can cube both sides. I can raise both to the 3/4, the reciprocal. So if I do both sides, if I take the 4th root of both sides, or the 1/4 power, to the 1/4, when you multiply your exponents, those cancel and we're left with x to the 1/3, and 81 to the 1/4, or the 4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. So the 1/3, now I can cube both sides, so the 1/3 and the 3 cancel when I multiply those, and I get 27. So we're going to go ahead and check for extraneous solutions and to make sure we did it properly. So 3 times 27 to the 4/3, and I want to know, does that equal 243? So I always suggest making your number smaller first. So 27 to the 1/3, I can write it that way, 27 to the 1/3 to the 4th. Remember, you just multiply your exponents, so I can write it as 27 to the 4th or 27 to the 1/3 to the 4th, either way. So if I do the smaller exponent, 27 to the 1/3 is 3. So I have 3 times 3 to the 4th. 3 to the 4th is 81, and we have to do the exponent part first. So 81 times 3 is 243. So 243 is 243. So it does check out. Let's move on to problem number 2. So I want to isolate the term with x in it, which is the square root. So I'm going to add 4 to the other side. So 2x plus 8 equals 10. To get rid of a square root, we can square both sides. So we have 2x plus 8 is 100, and then just go ahead and solve it all the way down, and you get x is 46. Okay, so we're going to go ahead and check. So the square root of 2 times 46 plus 8 to subtract 4, does that equal 6? 46 times 2 is 92, plus 8 is 100. We're going to take the square root of 100, subtract 4, and the square root of 100 is 10, so 10 minus 4 is 6, and we get 6 equals 6. So that works out. And let's go ahead and move on to problem number 3. So in problem number 3, we have two terms with the square root in it. So, and to undo a square root, we need to square both sides. If we square both sides now, which is legal, we'd have 0 squared on the right side, but on the left-hand side, we'd have like a big foil box method thing, which would just be ugly. You can do it, ugly though. It'd be better to bring that term to the other side before you square both sides. So we have 4x plus 28, we're taking the square root of that, bring that term to the other side. Now we can be in a better position to square both sides. And you have to be careful to square the 3 part too. So you get 4x plus 28 is 9 times 2x. We square the 3 and we square the square root of 2x. So just simplify and bring terms over. So we have 18x is 4x plus 28. Bring 4x to the other side. 14x is 28. And divide both sides by 2, and we get x equals 2. So we need to check. So you should always check because you're going to have extraneous solutions. So 2 times 4 plus 28 minus 3 times the square root of 4. 2 times 4 is 8, plus 28 is 36. The square root of 36 is 6, minus 3 times the square root of 4, which is 2. That equals 0, and we wanted to confirm that it did equal 0, so it does check out. And that is problem number 3. So let's move on to problem number 4. Problem number 4, same idea. We're going to bring it over. So I encourage you to pause it now and see if you can solve it on your own. So I'll go ahead and solve it. You should pause it and see if you can solve it. Okay, so we're going to bring it over. So we have 2x plus 1, and we're taking the square root of that. is the square root of x. Square both sides. 2x plus 1 equals x. Bring x to the other side. Bring 1 to the other side. X is negative 1. So we're going to check it. The square root of 2 times negative 1 plus 1 minus the square root of negative 1. Does that equal 0? But right here, we cannot take the square root of a negative 1, which tells us that x equals negative 1 is an extraneous solution. So in this case, it's not a solution, so I'm going to cross it off. In this case, we have no solution. So extraneous solutions will pop up when we end up plugging it back in and we take a square root of a negative number. Remember, it's legal to take the cube root of a negative number, but not an even root. So we end up with extraneous solutions when we end up taking the square root of a negative number. This doesn't say that any negative number is going to be extraneous, because if we looked at just the the left-hand term, if we plugged in some numbers under here, we could still plug in negative numbers for x and get a positive number underneath, which wouldn't cause it to be extraneous if only the first term was involved, if it was a different problem. So just because it was negative here doesn't mean you should discount all negative answers. Okay? So let's move on to the last problem, problem number 5. Okay, so let's go ahead and do problem number 5. So for problem number 5, we do need to square both sides. And when we square both sides, you do need to remember that it ends up being a FOIL problem. So we get the square root goes away, and when we square the right-hand side, we're going to write it out twice, and we're going to FOIL it out. So we get x minus 5, and 4 minus 2 root x minus 2 root x, so minus 4 root x, and root x times root x gives me x. And then I'm just going to group everything to one side, so my x's cancel, and I'm going to add 5 to the other side to get 9. I'm going to add 4 root x to the other side, divide both sides by 4, I get root x is 9 over 4, and then I'm going to square both sides, and I get x is 81 over 16. Then we need to go ahead and check. So I'm going to check for extraneous solutions. I get 81 over 16 minus 5. Does that equal 2 minus the square root of 81 over 16? Okay, so the right-hand side, 2 minus the square root of 81 over 16. Square root of 81 is 9. Square root of 16 is 4, which is 8/4 minus 9/4, which is negative 1/4. So right now I know that I have an extraneous solution, because I'm going to take the square root of whatever number this is on the left-hand side. When I simplify this left-hand side, I'm going to get 1 over 16. And when I take the square root of 1 over 16, I know I'm never going to get a negative answer. So I know that this is going to be an extraneous solution. But I go ahead and simplify it all the way out. The square root is 1 over 16. Take the square root of the top, which is 1. Square root of the bottom is 4. 1/4 does not equal negative 1/4, which tells me that this is an extraneous solution. So the answer to this, or the solution to this problem, is that there is none, no solution. Okay, so here a no solution, an extraneous solution, came out as a positive number, and the way it presented itself is 1/4 equaling negative 1/4. So generally speaking, when you have extraneous solutions, they appear like in problem 4 when we took the square root of a negative number, or when you end up with your check where they're really, really close, like 1/4 equaling negative 1/4. If you do your check and you get like 9 equals negative 17 over 2, that means you did something wrong. The extraneous solutions just when you take the square root of a negative number, or if they're super close, 1 positive, 1 negative, or some sort of relation otherwise. So that is all. I hope you have a jolly good evening, and alas, we are done.